Hello again, astronauts. Today I will be interviewing Jessica K. Lang. Jessica K. Lang is a senior research specialist at Harvard T.H. Chan School of Public Health, where she works in notobiotics. The lab's research focuses on the microbiome, the gastrointestinal immune system. Not only is Jessica K. Lang responsible for equipment maintenance, staffing, and ordering, but she's also involved in the research, creating protocols, sustaining notobiotic breeding colonies, and performing biological testing. She also makes mice germ-free. Hi there, Jessica. Thank you so much for agreeing to be interviewed.
Hi, Astra. Thank you for having me on your show.
So could you explain to me real quick, what is a microbiome?
So the microbiome essentially is all the teeny tiny parts of an environment. So in our lab, we look at the gut. So it's all the tiny things like the bacteria, the viruses that live inside the gut.
Okay, so you study mouse guts.
Basically, yes, in very simple terms.
Okay, so microbiome, tiny biome, that makes sense. And yours is the mouse gut. So second question, what is notobiotics?
So notobiotics, when you break down the term, it means known life. So in our case, the life we're looking at is bacteria, like you said, in the gut. And in my facility, we look at these mice that mostly have no microbiome. So they are germ-free animals. So these mice have to live in these specialized environments. They look like giant boxes or bubbles. And everything that comes into contact with those animals is sterile. So their food, their water, their bedding, anything that comes into contact has to be clean. So I work in a very clean mouse environment.
Okay, so I have several questions. Most of them are why. Why are you so concerned with making sure you have really healthy mice? Are you just like an overenthusiastic mouse mom, or?
That's a very good question. So the reason we take away the microbiome is so that we can create our own. So we often will reintroduce one bacteria, sometimes two, three, four. Sometimes we introduce whole microbiomes, even of people. So you can actually take a human microbiome and stick it into a mouse and then study the effects of that particular human's microbiome on a mouse. So that's why we do it.
So you take a person's gut bacteria and put it in a mouse and see what happens?
Essentially, yes, we do studies like that, yes.
That is so cool. So are you often studying like what certain bacteria does in isolation? Are you like putting a person's, gut biome into a mouse's gut biome to study that specific person? Or do you get a bunch of people? Like, I guess I have follow-up, but whys.
So it depends on the study. So what I do is I manage the facility, and then I work with a lot of the PhDs, the postdocs, and the students that do their own projects. So it really is project specific. Sometimes we'll take one particular bug and we'll give it back to the mouse and then see the particular effects. And we can also, in addition to altering their microbiome, we can also alter other things. For example, we do a lot of diet studies. So it's really interesting is you could take a particular strain, bacteria, give it to a mouse, and then look at a different diet. So for example, you could look at like a Western diet, versus the classic American diet, say.
Have you ever put a mouse on Atkins?
It's funny you mentioned that. We have a researcher now that's looking into a ketogenic diet for these mice.
These mice are healthier than me. You've got mice on keto.
So it does happen for sure. We actually also have mice right now. Half of them are on like a vegetarian, I'm using that word very, very loosely here, but a vegetarian diet versus a meat-based diet.
But do the mice even lift though?
They don't.
Yeah. Okay. So it's just They're trying to get their gains with just the diet and not the exercise. Come on, mice.
I'm sure, in fact, I know that there are labs out there that are notobiotic that have actual running reels where they'll look at exercise, but we don't do that in my lab, unfortunately. So that would be pretty cool to see them on their little treadmills.
I really, as someone who recently got into exercise, I feel like it would have been much more pleasant if I had just gotten some mice and made them exercise.
No, I feel you on that.
Yes. So you mentioned that you oversee a lot of PhD students and their research projects. Do you have any favorites aside from, of course, your swole diet mice?
Favorite projects?
Yeah.
Mm-hmm. Not favorite PhD students, because that
Oh,
one's
no, you
fair.
can't.
To be honest, no. I think my position is very unique because I do get to be involved in everybody's projects, and there's not one of them that I'm more passionate about than the others, because that also wouldn't be fair. A lot of the time I am blinded though, a lot of the time, and it's almost preferable that I am, because I don't want my hands to influence anything that they're doing. So a lot of the times I don't know what their predicted outcome is from their hypothesis.
Wow. So sometimes you're just taking care of mice and you have no idea what they're supposed to be doing?
Exactly. I mean, I know a little bit, but I don't like to know too much, because again, I don't want to be the one that influences the outcome. So for example, on a diet study, I know the postdoc knows what they think will happen to the mice on that particular diet, but I don't particularly want to know until the end.
I mean, that makes sense. Are you also cataloging your observations of the mice? So are you kind of like that neutral party observer?
Exactly, I am. In fact, we just did a study with tumors. And again, I really wanted to go into it blindly. So even my measurements, like I was very careful to like not even look at which group I was trying to measure the tumors for, just again, to be as neutral as possible.
Yeah. And I think a lot of people don't necessarily know what we mean when we say like blind studies or double blind studies or neutral observations or like attempted scientific neutrality or objectivity. And I think your explanation is really helpful because you don't want what you think should happen to bias the results, because you don't want to know what you should be looking for.
Exactly.
So, what are the real world, like future medical applications for the type of work that's done in your lab? Like, are these people working toward improved medicines, dietary recommendations? What's the end goal, I guess?
That's a very good question. We are mostly a basic science research, although we do some translational studies as well. But I think the overall arching goal is to, find out more. Just find out more information. And, eventually it gets up the chain to, clinical trials and drug testing. But in academia, you want to know more.
Yeah, you want to learn for learning's sake. That's awesome. So, what's it like working in a sterile lab like that?
So I work in two different places. I work in the gnotobiotic facility, which is in a sad basement where most animal facilities are, unfortunately. So that part's a little, you're in a basement. But working in the actual lab upstairs, it's really, one thing I like about working in science is there's a lot of variety in what you do. So one day you could be pipetting at a bench. Another day you could be working one-on-one with the animals. Another day you could be doing an experiment somewhere else, doing like flow cytometry. That's not something I do, but like my coworkers get to go off and do all these fun things. I spend most of my time in the basement with the animals.
Yeah, that's very reminiscent of my undergraduate and master's research in a nanomaterials lab. It was also in a basement. It was not sterile though. It was not close to sterile. So, do you have any funny stories from your career working with lab animals?
I do. There's one that stands out that's particularly amusing. So, like I said, I work with germ-free mice. So a lot of the work we do, actually, I should say, all the work we do is in a sterile environment. So, like I talked about the isolators being these giant boxes, and they have gloves that come up to your armpit. But I also work in a biological safety cabinet. It's like a cabinet with circulating air, and if you're doing work inside of it, it's sterile air. So I do a lot of my mouse manipulations inside a biosafety cabinet. And there was one time, this happened a couple of years ago, where my boss had given me a very sacred sample. It was I'm going to use the word top secret project. To this day, I'm still not sure what that project was for. But she was very specific, and it was a very important study. And I'm in the middle of doing my work, and then all of a sudden, whoosh, and there's a fly that went through the airflow, and the biological safety cabinet, remember, has constant airflow. So this fly flew in and landed on the wall of the hood. And there was nothing I could do, because I'm in there sterile, I'm covered in chemical, everything is happening. I'm wearing like gear, to keep everything out. And it was just, that was particularly amusing. The great thing is that the study ended up being, it was supposed to be a germ-free thing that we were doing, and thankfully the fly didn't introduce any additional bacteria to the study. But that was definitely an amusing moment in my career of notobiotics, and to explain that to my boss, like,
that sounds like it's amusing in hindsight, but in the time would be incredibly stressful.
It was very stressful, because what do you do? Like, there was nothing I could do but just keep doing my work and hope that the fly didn't land on the mice.
I guess maybe just like yell at the fly. I don't know.
I did get a picture. I did get a picture of it. My coworker got one because she was in the room.
So we've talked about your work with germ-free mice. How do you make a mouse germ-free?
That is a very good question. So you can order them in, or you can create them yourselves if you have an Adam and Eve that are already germ-free. So the process sounds very easy, but it's incredibly difficult, because a lot of it is dependent on the mouse gods. And what I mean by that is, we have a donor of the particular mouse strain that you're looking at. So say you wanted to make a diabetic mouse germ-free, you would have a regular mouse that's, I'm going to say dirty, but I'm including myself as being dirty because the environment is covered in bacteria. So you take a regular mouse, dirty mouse, then you take a germ-free mouse, that's going to be your foster. So you have to have a foster to accept the pups from the dirty mouse. That donor mouse, you get pregnant, and you get the foster pregnant in tandem. The donor, you're going to do a C-section, remove that uterus, put it in a chemical bath that's going to completely sterilize the outside sac where the pups are. Because remember, inside the uterus, the animals are germ-free. There is no bacteria inside. Then we hatch those pups, and we essentially give them to a foster mother who is germ-free. If we are very lucky, that foster mother does not reject the pups that are not hers. She accepts them as their own. If we are very lucky, that entire process is done sterilely, because it can often become contaminated. All it takes is one bacteria, and as you know, the world is a bacteria soup.
Yep.
And if we're lucky, even again, it's the right genotype of the mouse that we need. So 5 steps.
Do I want to know what happens to the original dirty mouse that you got pregnant?
Unfortunately, it is a terminal procedure, because I do have to take out her entire uterus.
And since you are doing these kind of procedures, what animal research ethics guidelines do you have to follow? Like, does the mouse have to be sedated? What are you doing to make sure that the mice, I mean, they live very short lives, but at least don't live too terrible lives?
So there's something called the Guide for the Care and Use of Laboratory Animals. And that's what we use as our baseline. We also do have IACUC inspections, which is an internal body of people at Harvard that review our protocols and make sure that everything is done appropriately. All the protocols and procedures are followed. That's one thing that I feel is a misconception working in lab animal science, or working in science in general. There are a lot of guidelines that need to be followed. It's not just people randomly doing things willy-nilly. There are a lot of guidelines that go into this.
So many people think that to pursue academic research in STEM fields, especially basic research, you pretty much have to get a PhD, but that is not true at all. I mean, you've been working professionally with lab animals in a university settings since 2009, and now you run a research lab at Harvard. So could you tell me a little bit more about your personal career path and why you chose it?
Originally, I wanted to be a veterinarian. I think that's almost every little girl's dream. We all kind of want to, play with animals. I fell into research animals accidentally, really. My husband got a job. I went down to Florida with him. I didn't really know what I was doing. I had a degree in science and education, but there was a job opening at the University of Miami, just working with research animals at the bottom, basically changing their cages. So I kind of started in that way. And then I worked my way up to veterinary technician because I did have a background working in a veterinary office. And people noticed that I was very, very detail oriented. And when you work in notobiotics, you have to be very detail oriented. It's probably the most important thing. So I haphazardly fell into this career. I do have a love of science, so I think that is also important. I think that's honestly the most important thing, is love what you do, because if you don't, you're going to be miserable.
Yeah, I think it's kind of ironic that most, you said it's every little girl's dream. Most children who want to be veterinarians realize that they don't because of all the sad parts. And it seems like you just kind of embraced and loved the sad parts the best.
I suppose that's true. Although ultimately, I think working with animals is really important. I don't need to include this interview, but I am a vegetarian, and I take it for over a decade. I should be vegan. So I do. I mean, the sad parts come with the happy parts. I'd rather it me being the one who's doing the sad parts, because I know it's going to be done properly.
That's a really cool way to look at it. Yeah. And don't worry about being vegan. Cheese and eggs taste so good.
Are you vegetarian too?
Oh, no.
Okay.
See, I want
no judgment.
But the bacon.
Bacon was hard. Also, I loved sushi, so sushi was really hard to give up.
Generally, like when I'm at home, I'll cook vegetarian for myself and my wife, but when we're eating out, we're just like, nope, scallops, bring them here. I'm ready for them to figure out how to grow meat. Once you can grow like a leg of lamb, I feel like
they're doing it.
I know
they are doing lab grown meat. There's lots of discussions. I've actually on Reddit, I think I was reading about them.
Yeah, I've read about it, and I'm like, I need it now though. So for people who are really interested in getting involved in research in a lab in an academic setting, what kind of advice would you give to people, both undergraduates and maybe working professionals who are thinking about going back into academic research?
I think definitely if you're an undergrad, try to do lab work at your school if you can. Like go in, volunteer, do internships. That's not something that I did and I wish I had done. Our lab is actually currently hiring, and we definitely look at people who have like a lot of, pre-existing experience. So I think that's definitely, if you can, when you're an undergrad, try to do that. And in terms of people that want to return back to academia, I will say it is a challenge. Academia, I think once you leave, it's hard to get back in. I don't particularly know why, but I know a couple of people that I've worked with in the past that have left and tried to re-enter the field. It has been a little bit of a challenge for them. But working in academia is fine. You won't make as much money as if you go into research. So let me put that out as a huge disclaimer. If you're working in academia, it's definitely not for the money. It's for the love of the science.
So you mentioned for students especially, you're actually hiring research assistants, and I will put the link down in the description. For people who are more casually interested, say they majored in physics and aren't really comfortable around chemicals because they had one too many spills in high school chemistry that really traumatized them more than they'd care to admit. How would you recommend some hypothetical person like that would keep involved in learning about animal research, casually keeping up with what your lab's doing and what other similar labs are doing?
I think honestly, going on Reddit is a really good resource. I know we do have a Twitter account. My lab personally has a Twitter account, so we post a lot of the papers that we publish. You can also reach out to me directly if you have any particular interest in notobiotics, but we are definitely all over Twitter. Harvard School of Public Health is also on Facebook. Like it's so easy now with technology.
So as I was LinkedIn stalking you before this interview, I noticed that for over 7 years, you were a volunteer foster home for rescue guinea pigs. Can you please talk about that? Because guinea pigs are super cute.
So when we moved to Florida, we had rabbits. My husband and I had 2 bunnies, and I always wanted guinea pigs. I think they are the cutest animal ever. They are very sweet, very vocal. Every time, you walk in the room, they would chitter chatter right at you. So I hooked up with a local rescue, and we basically fostered guinea pigs. Most of the ones we fostered were non-adoptable. A couple of them were. In fact, we also adopted 2 of them while we were fostering, because of course you're going to fall in love with them. Of course you are. But a lot of the ones we did were special needs guinea pigs. We had one that was blind named Sammy. He was a long-haired guinea pig. Oh, poor little Sammy. We had a couple of others. We had one named Miley. I think Miley had some sort of tumor, some sort of growth. So we basically made them like a happy place to live during their time.
Oh, that's so sweet. I love that. Thank you so much again to Jessica K. Lang for stopping by and talking to us about notobiotics and about working with animals in an academic lab setting. Remember to keep seeking out science, and remember that science is a process. Have a great day, and I will see you next week. Astra out.
Ad Astra, to the stars, to the sky.